Hey, it's Jillian. We're going to take a look at the second kind of factoring special quadratics, which is perfect square trinomials. So here, what they want you to see is that when you, and we already know we went from here to this way, now we're going here that way. So when you have this, when you have something squared here, and the center term is whatever you squared here and whatever you squared here doubled, you have a perfect square trinomial. So let me show you. I think it's easier to show you. So here we have m squared, we have 7 squared, and here we have doubled m times 7, right? That m, the square root of that there, and doubled. So now when we have that, that whole thing equals the first m, the last 7, and then the sign here is always the sign of b. So the sign of b was negative, b being a, b, and c. That's it. So let's see here. The square root of that is this. The square root of that is this. The sign of that is there. Now let's check to make sure this is a perfect square trinomial. This times this is 10x, doubled is 20x. We're good. Let's do another one. This square root is that. This square root is that. This sign is that. And this times this doubled is not that, so it's not a perfect square trinomial. No, thank you, not equal. This would have to be what number? Correct. This times this doubled is 10x. Okay, let's do these. Here, what we need to make note of is it doesn't matter what this variable, what this exponent is. What matters is that it's double this one. Like that 2 is double 1. This 10 is double 5. So let me show you what I mean. Here, I'm going to rewrite this as x to the 4th squared minus 24x to the 4 plus 144. So you can see it's like an x squared, an x, and a constant. Now let's see what happens here. So here we've got, this will be x to the 4. This will be, the square root of this is 12. The sign of this is negative. And then let's see, is this times this doubled that? It sure is. 12 times x to the 4 doubled. 12 doubles is 24. We're good. Let's, hang on, I'm just going to move this over, some prime real estate over here. So here we're going to have y to the 5 squared plus 2y to the 5 plus 1. So y to the 5 will be in our bracket, whatever it is squared. The square root of that is 1. The sign of that is positive. And now what we need to do is this times this doubled this number. Well, 1 times that is y to the 5, and 1y to the 5 doubled is 2y to the 5. So we're good. Unlike when we weren't good up here, because that wasn't a 10. Now let's see this one. This one is, I mean, I know this because I've done many questions, but what I want you to see here is that you have 4 terms. These 3 sort of go together as a perfect square trinomial. And then this will become a difference of squares. Let me show you what I mean. So here we have x. The square root of that is 3, and 3 doubled is 6. So that's going to be a 3. That's a square. The sign of that is negative. So x minus 3 all squared, or x minus 3 times x minus 3 will FOIL out to this. And then we have this. So now we have what we had in the previous video, which was the first kind of special quadratic, which was a difference of squares. So now we have x minus 3 w plus and minus. So this is x minus 3 plus w, and this is x minus 3 minus w. There's nothing else to collect, so we just leave it like that. And now let's do something similar to what we did last time with the difference of squares. Determine the value of k so that each trinomial is a perfect square. Okay, so here we already did a question like this up here. So no problem. This would be a perfect square trinomial if this was 3x, this was 5, and this was positive, right? So that means that this k has to be 3 times 5 doubled, which is 30, because 3 times 5 is 15. Okay, let's take a look at this one. Here, so we're going to try an unknown here for B, an unknown for C, and an unknown for A. Let's see how we do. So here, this would be 4x squared would be 2x. The sign would be negative. And what times something doubled is 12? 2 times what, and then doubling it is 12. Well, let's try 1. Is it 1? Is 2 times 1 doubled 12? No, 2 times 1 is 2. Doubled is 4. What about 2? Is 2 times 2 4 doubled 8? No. What about 3? 2 times 3 is 6. 6 doubled is 12. So that's a 3. So if that's a 3, when we square this out, what's that k need to be? That k is going to be this squared, so k will be 9. So as you can see, this is a communication thinking problem, and given this on a test, you would have to write up in a few short sentences basically what I've just talked you through. Okay, let's take a look at what happens when a is our unknown. So what are we going to have here? Well, if that's 16y squared, back here will be a 4y. And you know there's going to be an x here. And you know the signs are the same and they're both negative. So we're just looking for this. So let's see. What times 4 doubled is 40? I don't know. I mean, you're going to soon just be able to look and figure it out, but if you get the wrong number and you don't know where to start, just pick a number. So let's say you've got 4. Is 4 times 4, 16 doubled 40? No. Then you might say, well, wait a minute, maybe it's easier if I just cut this in half, 20, and figure out 4 times what is half of that. Maybe that's an easier way to do it. So half of 40 is 20, and 4 times 5 is 20. So if that's a 5, then 5x is what will k be? Well, k will, of course, be 25, because 25x squared is the same as 5x all squared. Okay, there's factoring your special quadratic.